Did you hear about the asteroid that's coming to visit in 2029? Probably not, and I don't blame you, because most days a rock floating around in space doesn't feel like your problem. But this one's different. This one is longer than a football field and stands about as tall as the Eiffel Tower. And on April 13th, 2029, it is going to come closer to you than the satellites beaming your television signal down from the sky. Let that sink in. There's going to be a mountain of rock passing below our own spacecraft, close enough that you'll be able to walk outside, look up, and watch it move across the stars with your own 2 eyes. No telescope, no binoculars, just you and a god of destruction sailing by. And April 13th, 2029, by the way, lands on a Friday. A Friday the 13th. You can't make this stuff up. Now here's the part that'll get your attention. For a while there, the odds that this thing would slam into Earth were 1 in 37. 1 in 37. That's not a lottery ticket. That's a coin you'd be nervous to flip. It is the highest impact probability we've ever calculated for a serious asteroid, and it earned this rock a name worthy of the fear it caused. We call it Apophis, after the Egyptian god of chaos and destruction. Here's the good news, and the twist. It is not going to hit us in 2029. But how we know that, and what would happen if we were wrong, tells you everything about whether we are actually ready. So how does a rock nobody had ever heard of become the most feared object in the sky? It starts on June 19th, 2004 at Kitt Peak in Arizona, where 3 astronomers, Roy Tucker, David Tholen, and Fabrizio Bernardi, spot a faint moving dot and start tracking it. And they get exactly 2 nights on it before the weather closes in and the equipment acts up. And just like that, they lose it. Gone. 2 nights of data on a rock we now know could ruin your whole century, and it slips right through our fingers. Lucky for us, a team down in Australia at Siding Spring picks it back up that December, and now we have enough to actually run the numbers. And the numbers are terrifying. At this point, it doesn't even have a real name. It's got a license plate, 2004 MN4, later filed away as asteroid number 99,942. Sounds about as threatening as a parking permit, right? But then you plug the orbit into the computer and out comes a 1 in 37 chance it hits Earth in 2029. 1 in 37. That's the highest impact probability ever calculated for a significant asteroid, a record this rock still holds. So overnight, this nothing little dot with a catalogue number becomes the most dangerous asteroid ever discovered. And you don't get a boring name after that. Tholen reached back into Egyptian mythology and pulled out Apep, the serpent of chaos and destruction, and we went with the Greek version, Apophis. And yes, for the nerds in the room, that's also the name of a villain from Stargate. But no, we did not name a planet-threatening asteroid after a television show. We named it after a god. It earned that. So, what exactly is this thing that had everybody so worked up? Let's meet the monster. Apophis is about 340 meters across, and its long side stretches out to around 450 meters, which means if you laid it down on a field, it would be a little longer than an NFL football field, and if you stood it up on its end, it would be about as tall as the Eiffel Tower. That's the object we're talking about. Not a pebble, not a boulder, a flying mountain. And it's not even shaped like a nice round ball the way you're picturing it. It's shaped like a peanut. 2 lumps stuck together in the middle, like the universe took 2 rocks and welded them at the waist. Now here's what it's made of, because that matters. Apophis is what we call an S-type asteroid, which is the fancy way of saying stony. Silicate rock packed with nickel and iron. This is not some fluffy pile of gravel loosely held together that would crumble on the way in. This is a solid rock, and a solid rock hits differently, and it's old. This thing is about 4.5 billion years old, a leftover from the day the solar system was being built, formed way out in the asteroid belt between Mars and Jupiter. And it would have stayed out there minding its own business, except Jupiter's gravity gave it a nudge, and another nudge, and slowly walked it inward until it started crossing Earth's path. Thanks, Jupiter. And here's my favourite part, the way it moves. Apophis doesn't spin cleanly. It tumbles end over end about once every 31 hours. And on top of that, it rocks back and forth with a slow wobble every 264 hours or so. It doesn't rotate, it staggers through space like a badly thrown football. Now the title promised you carnage, so let's do the math. And let me be crystal clear before I do, this is the what if. It's not going to hit us. But you don't understand why we care so much until you understand what a rock like this actually does when it arrives. Because here's the thing about a 340-meter stone traveling at something like 30,000 miles per hour. It doesn't land. Landing is a gentle word, a word for airplanes. This detonates. All of that speed becomes energy the instant it touches down, and it lets that energy go all at once. Now the good news, if you can call it that, is that Apophis is a city killer, not a dinosaur killer. This isn't the rock that ends all life on Earth. This is the rock that ends a very bad afternoon for a very specific region. So where does it come down? Say it hits the ocean. You cavitate the water, you punch a hole in the sea, and the sea does not appreciate that. It fills the hole back in, splashes up, and sends a wall of water racing outward toward every coastline in reach. Or say it comes down on land. Now you've got a crater a couple of kilometers wide and a blast wave rolling out in every direction, flattening everything for miles like the world's worst pressure washer. Either way, it is a very bad day to be standing anywhere nearby. And here's the part I want you to sit with. This is precisely the size of rock we cannot afford to be wrong about. Too small to see coming easily, too big to shrug off. Which is exactly why the next part of this story matters so much. So, if this rock is a city killer, and for a while we thought there was a 1 in 37 chance it was coming for us, why am I sitting here so calm? Let me tell you about the Keyhole. In space, there's this tiny region we call a gravitational keyhole, and it works like a trapdoor. If Apophis passes through that exact little patch of space in 2029, Earth's gravity grabs it and bends its path just so, just enough to line it up for a direct hit on a later trip around the Sun. Miss the keyhole, and you sail on by, no problem. Thread the keyhole, and you've got a date with Earth years down the road. So, for a long time, the real nightmares weren't 2029 at all. They were 2036 and then 2068. Now here's what makes this genuinely hard. And it's the weirdest thing. So, stay with me. There's this thing called the Yarkovsky effect. Sunlight hits the day side of this tumbling rock and warms it up. And as it rotates, that warm side turns away and radiates the heat back out into space. And that little puff of heat leaving the surface acts like the world's tiniest engine, giving the asteroid a gentle, constant shove. It's almost nothing. But over years and years, that almost nothing adds up, and it can be the difference between missing the keyhole and hitting it dead center. Good luck modeling that. So how did we get out of this? In March of 2021, Apophis made a distant pass, and we hit it with radar, and pinned its orbit down with real precision. And the verdict came back. No impact for at least 100 years, keyholes included. And listen, that wasn't luck. We didn't get saved, we calculated our way out. Isaac Newton bailed us out again. So if it's not going to hit us, what actually happens on April 13th, 2029? You get the best seat in the history of seats. Apophis is going to pass about 20,000 miles above the surface of the Earth. Now that number probably doesn't mean much to you, so let me put it in perspective. Our geosynchronous satellites, the ones handling your TV and a chunk of your communications, sit up there around 22,000 miles. So this asteroid is going to slide in underneath our own spacecraft. A rock the size of a city block, passing closer to you than the satellites you use every single day. Let that land for a second. And you won't need a fancy setup to see it. No telescope, no binoculars, no observatory. If you're anywhere in the Eastern Hemisphere with a clear sky, you walk outside, you look up, and there it is. A bright point of light sliding across the stars like a fast-moving satellite that forgot to check in. A rock this big coming this close happens about once every few thousand years, and this is the first time in all of human history we'll be around, and smart enough to actually watch it happen. And here's the part the astronomer in me can't get over. When Apophis swings by that close, Earth's gravity is going to reach out and grab it. Pull it, twist it, stretch it, squeeze it. It's going to enlarge the asteroid's orbit, stretching its year from about 9/10 of ours to closer to 1.2, which literally reshuffles it into a whole different class of asteroid. It'll probably tweak that tumbling spin, and it may even shake loose small landslides across its surface. We are going to sit here and watch a planet reach out and rebuild a mountain in real time. Now here's the part that gets me really excited, because we are not just going to sit back and watch this thing fly by. We're sending company. Remember that spacecraft called OSIRIS-REx, the one that flew out to the asteroid Bennu, grabbed a handful of it, and dropped the sample back to Earth in September of 2023. Well, that spacecraft didn't retire, it didn't go home. We renamed it OSIRIS-APEX, pointed it at Apophis, and sent it right back out to work. It's going to trail the asteroid by about an hour, slingshot off Earth's gravity, and then settle in for an 18-month campaign mapping every inch of this rock. And here's my favorite move. It's going to dip down within about 15 feet of the surface and fire its thrusters, blasting the loose dust aside so we can peek at the fresh material underneath. No sample this time, just a really good look, and it's not going alone. The Europeans are building a spacecraft called Ramses, aiming to launch in April of 2028 and arrive in February of 2029, so it can ride shotgun through the whole flyby. And down here on the ground, a worldwide network of astronomers is coordinating to watch every second of it. But here's what all of this really is, when you strip it down. It's a dress rehearsal. We've already proven we can crash a spacecraft into an asteroid and nudge it off course. We did exactly that. So Apophis isn't really a threat anymore. Apophis is practice. And that flips the whole question on its head. The title asked whether we're ready if this one hits. But that's the wrong question. The real one is, when the next rock lines up for the keyhole, and one of them eventually will, are we going to be ready for that? So let me leave you with a different way to think about Apophis, because we've been calling it a monster this whole time, and I don't think that's quite right. Apophis is a gift. It really is. The universe scheduled us a live fire drill, gave us decades of warning, and handed us a real rock to practice on without a single life on the line. You could not design a better rehearsal if you tried. And look at what we did with it. We found it when it was nothing but a faint dot. We ran the numbers and got scared. Good, we should have. Then we chased it down, hit it with radar, sharpened the math, and ruled it out. And now we're flying spacecraft alongside it just to learn everything it can teach us. That right there, that whole arc, is what it looks like when a species grows up. Here's the thing I keep coming back to. The dinosaurs got no warning. No faint dot, no radar, no countdown, and definitely no space program. They were just standing around one afternoon, minding their business, and the sky decided their story was over. We are the first creatures in the history of this planet who get to see it coming. We have the eyes, we have the math, we have the machines. The only thing left in question is whether we treat April 13th, 2029 like a fireworks show, or like the rehearsal it actually is. Because being smart enough to see the rock coming is only half the job. The other half is being wise enough to do something about it. The dinosaurs never got that choice. We do. Let's not waste it.